All right, so when we talk about distance on the number line, we are talking just really basic stuff initially. So the first thing I want you to do is on your paper, draw yourself a number line. Just go up from 0 to 4, so put a 0 in the middle, just go 1, 2, 3, 4, and then do the negatives of them or their opposites like that. Now the first thing we're going to look at is like the distance between 2 points. It's really simple, okay, and it's meant to be simple. If I had a point right here, and we're going to call that A, and I had a point right here, and we're going to call that B, and I were to ask you, how far is A and B apart? Like, what is their distance? How many spaces? Yes, sir. Not 4. Look at that one more time. Yes, ma'am? 5. Okay, now, how did you get that?
I counted B and
okay, basically you just counted from here and just went over. So 1, 2, 3, 4, 5, right? Mm-hmm. Okay, so we know that the distance from A to B is 5. And I'm going to write that like this. Okay, that little line I put above the AB means it's a line segment. Okay, we'll talk more about that later this year with how to do notations for that. But we can just write it like that for right now. Now, I need to know, how can I find that distance without just seeing the number line though? What function can I use to find distance? And I mean adding, subtracting, multiplying, or dividing. How could I find distance using adding, subtracting, multiplying, or dividing? One of those will let me do it.
Add?
You wouldn't add. Because if I ask you how far it is from here to the mall, okay, you'd have 2 locations and you'd have to do something between them. You would subtract them, okay? This number A, or point A, is at -4. This point is at 1. Which is the bigger number, 1 or -4? 1. So I'm going to start there. And I'm going to say, to go from B to A, I'm going to take 1 minus 4, -4. So I started with my first point B, and I'm trying to go to A, so I'm going to minus -4. If I wanted to go from A to B, I would go -4 minus 1. Now I want you to see what happens with these answers. Using our rules for integers, what do I have to do here with there's 2 negatives in the middle, Nicole? What? Yeah, bring them together. They make that plus. Now, what would 1 plus 4 be? Yes, ma'am? 5. That was pretty simple, wasn't it? This one from AB, -4 minus 1. Using integer rules, how much would that be? Yes, sir. 5. Nope. Using integer rules over there, Brooke, -5, right? There is one special thing, and this is kind of important. If I was asking you the distance of something, could distance ever be negative though?
No.
No. So in this case, write that down. Distance is not negative. So in this case, instead of it being -5, once I get that answer, what do I have to find? And the hint is, we did it at the beginning of this chapter, and they look like vertical lines. What is that? Yes, sir? The absolute value. Technically, we're taking the absolute value of both things. So this one will still be 5, and this one will become 5, so that the distance is still 5. Okay, so it doesn't matter which way you count. Whenever you're finding that distance, that's always the absolute value. Okay. Now, go ahead and go to a next topic. That was distance. Oh no. Now, write this subtopic down there. Number lines, addition, subtraction. There's two types of problems on your homework tonight. There's two different types of problems on your homework tonight. What a trick question. Now, if you have points on your line, on your number line, I need to know the length of something, and I can tell how far those points are from each other every time. So if I have a number line, go ahead and make one. Let's make it 0 right here. We're going to make it 6 on the right, negative 6 on the left. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, etc. Now I'm going to pretend for a second that I have a line. And the line is called XY. Okay? That XY line is going to be 4 long. Okay, that's how long the line is. I'm going to tell you X is at 3. And I want to know, where is Y? Where could Y be? This is the one that's a little bit harder. It really makes you think about a number line. A lot of people in some other classes had some difficulty with this. Okay? Yes, sir? Okay. You think it's at 1. So he's saying if X is at 3, which is right here, could Y be at 1? Would that be 4 units away?
No.
Sorry, bud. Could it be, though? No. So let's look at that number line one more time. Where do you think it is?
-1.
Could it be at -1?
Yeah.
Yeah. We can do that because, look, boom, 4 spots. 1, 2, 3, 4. -1 could be an answer.
I thought you counted the one that the dot was on. That's what we did the last problem. So then we did 0.
Wherever you start, that doesn't count as 1.
Well, that's what we did for the last problem.
No. No. Because it's 1 through 5. Right here is 1, 2, 3, 4, 5. Okay. Now, where else could it be, though? I could go this way, but couldn't the number also go the other way as well?
Mm-hmm.
So if I went 4 the other way, 1, 2, 3, 4, I'll extend my number line. It could also be here at 7. Do you see that? That way XY would be either here or to here. And that's how long it would be. Yes, sir?
I feel like if your thing is at 6, your number line go to 6, and then it's going negative. I thought they had to go like 6, and then -6, and then -5.
It's like that. The number gets closer to 0, negative, like that. All right. So if I had an answer for this, where could Y be located, basically? It could be at -1, or it could be at 7. Now, there's an easy way to do this problem, and this is what you'll really need to pay attention to. If I know that X is at 3, how do I get to 7 from 3?
Move up.
Using math. How would I get from 3 to 7? Add how much?
4.
Add 4. How would I get to -1 if I started at 3? Using math. Subtract 4. So if you do this, if you know where you're starting from, and you know the length of the line, all you have to do is take where you start from, so this is your starting location, this number right here is the length of the line, and then these two would be your answers. You'll see this when you get to a problem that looks exactly like this on your homework. This will probably make a little bit more sense. Okay? But always take your starting location and you can add, and that'll go to the right. You can subtract, and that'll go to the left. Now, are we good? Okay. Draw another number line, but shorter. Let's make it one more. It's still under the same topic. But let's start at 0. Let's go 1, 2, 3, -1, -2, -3. I'm going to make this easy.
Well, I like move over here.
Yes,
over
yes,
a little bit.
yes. Go there. Just for right now, just go there. Take that. Okay. Then there's another type of problem. It says this. Let us pretend for a second that you are at -1. We're going to call that A. If I want to move, if I start at -1, and I move 2 spaces right. This is how the question is going to look on your homework today. Where will I end up first off? Yes, sir.
End up at 1.
I would end up at +1, wouldn't I? Because that's 1, 2 to the right. How would I show that as a math problem? Give it a shot.
Add 2.
Tell me what to write down, the whole math problem.
-1 plus 2.
Okay? Does that make sense? If you are moving 2 spaces to the right, that is a +2, isn't it? Okay? What if I start at -1 and I move 2 spaces left? My question is, where would I end up? If I'm starting at -1 and I move 2 spaces left. Nate? -3. Well, how would I set up the problem? I know I'm starting here. I'm going to -3. How would I set up that problem? -1 minus 2. Okay? Now, does that make sense? Okay? This is where the harder part comes in. What if I take these two problems and I want to change out their signs? Meaning, I'm going to take this one and I'm going to write it another way. I'm going to take this one and write it another way. I want to take this, and instead of it being an addition problem, how could I change that to a subtraction problem? But yet still keep it the same. Same answer and everything. Yes, sir?
Can you flip it?
I can't just flip it, because if I want to keep them in the same order, because that's where I start, and this is what I have to do to it. What do you think?
-1.
No, that's what he was trying to do. He's trying to flip it around. I don't want to flip the numbers. I still want a 1 and a 2 here. The 1 has to be negative, and the 2 can change a little bit, but
Did you just use the different sign?
kind of. You're getting closer.
So you would take -1 and then put minus and then put -2 in parentheses?
Yeah. Remember how we told if two negatives come together, they make a plus, right? Well, can't the plus be taken apart then? I use my example of dancing. If you're dancing and you come together, well, eventually the music stops. So you can always go back. Okay? So, in this situation, this problem right here is the same as this problem. It looks completely different though, doesn't it? But didn't we say also the other day that if you have two negatives in a row, they have to come together before you start dealing with the rules? Okay? So I just need for you in your head to know that this and this is the same exact thing. Now down here, how would I take negative 1 minus 2 and change that to an addition problem? What do you think?
You could make 2 negative and change the minus to a plus.
Change the what to a plus?
Minus.
I see what you're saying. He said, make 2 negative, like this, and then put a plus there. Do you see that? This is the same problem as that. Okay? That's just hard for people to see. Write this down, because this will be on not only your test, but also the homework that you're going to have today. Okay? This one's a little bit harder. Hopefully I can help you a little bit if we get stuck, okay? I think these are like problems 7, 8, and 9, or 7 and 8 and 9, or 7 and 8. I don't know. Might be only 2 problems. Okay. Do we have it written down so we can come back to it? I'll wait a second. The next section is going to be order of operations. We're going to do 5 problems, because we already talked about this yesterday, but we're going to make them starting off a little bit slow, a little bit easy, and then they're going to get hard. Okay? Because we're going to do all order of operations all together. All right. Whoops. Now, first off, order of operations. What is the acronym for order of operations? Yes, ma'am? Yeah, PEMDAS. P-E-M-D-A-S. I write my PEMDAS like that. Did any teacher last year write it like that? No? Some did? Okay. There's a reason for that. We always, when we do PEMDAS, we start at the top and we work our way down, don't we? So you start here, then we end here. But if you get to these levels, they are on the same level, and you always do them the same from left to right. Now let's talk what these symbols mean, just so we have it out there. What does the P stand for? Raise your hand. Let's go. Seth? Parentheses. Here's what it looks like. But it doesn't just mean parentheses. It means grouping symbols. There's 2 more that you probably should know. Parentheses, brackets, they look like this. Those are just parentheses. And then there's my favorite one. It's hard to draw them sometimes, but those are called bracers or braces. Okay? What does the E stand for? Exponents. Here's my example of an exponent. This little guy is called the exponent right here. I guess it could be a little girl too. Now, M and D, of course, stand for what? Okay, we show them like this whenever we do this. But the multiplication symbol will no longer be an X after today. You might see it once or twice today, but once we start dealing with variables, that X no longer will be a multiplication sign, okay? We show multiplication by the dot, and that's even rare, but mainly by parentheses touching other parentheses like we did yesterday, okay? And we'll look at some examples like that here in a little bit. The division sign. More than likely, you won't see the division sign very often. Who remembers how we write them now? Yes, sir? You can. What does that make it?
A fraction.
A fraction. Because a fraction is simply a division problem, but you don't want to make it like this. This would be like an okay way to write a fraction, but whenever we start doing stuff, you wouldn't want to write it like that. So you'll probably see it like that. At least whenever I give you something, you will. Addition and subtraction is the last one. Those symbols never change, okay? Even though we said they could mean positive and negative now, they're still addition and subtraction, okay? That symbol will not go away for any reason. Now, that's the introduction. Do we all remember these things now? Kind of? Okay, let's look at an easy problem. This one's going to be super easy. We're just going to use whole numbers, no negatives. Here it goes. And this is the first example. Let's say I do 5 plus 3 times 6 minus 8. Now I'm going to use two different colors here. I need to follow order of operations. Check every time. Do I have parentheses? No. Do I have exponents? No. Do I have multiplication or division? Yes. The little dot is multiplication, right? So I'm going to first handle the multiplications. What is 3 times 6?
18.
18. So I'm going to write it. There's 18. And then I'm going to write everything else around it. If you are going to ask me a question, please, 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 if you have the problem that's an order of operations problem, have it written down on your scrap paper first. Because I don't think a lot of us, no offense to anyone, but a lot of us can't remember if we have a big, long order of operations problem, we can't remember all the little steps we did in our head. And if we make a mistake, it's really hard to see where you messed up if I can't see it. Okay? So, what do I do next? Nate? 5 plus what? Sorry. 5 plus 18. So how much is that, sir? 23. And then I write down everything else. Now, what's the last step I have to do here? Yeah.
23 minus 8.
Yeah, which is how much? 15. Very good. Again, that's the easiest problem you'll have. Okay, you still have to follow order of operations. You got to remember to do multiplication or division first. Okay. Now, let's look at a problem, but this time with integers. Okay, so we're going to have some negatives thrown in here. Can I erase this?
Yeah.
All right. Let's throw in some negatives. So this question or problem 2. Let's pretend I have negative 7 minus negative 15 divided by, I don't know, negative, or let's just do 3. We don't have to make everything negative. So, as you're doing this, negatives are very important. We have to check for what first? We talked about it yesterday. Not parentheses yet. What do we always have to check for when we see a bunch of negatives? If they're touching, if they're in a row. Okay? These two right here are in a row. So they're going to have to come together and make a plus. So I'm going to make these two into a plus, and then I'm going to rewrite the whole problem. Negative 7 plus 15 divided by 3. Now we use order of operations. We look for parentheses. Well, there aren't any. We look for exponents. There aren't any. Woo! Okay. Next, multiplication division. Max, you see any of that?
Yeah.
Where you got it?
15 divided by 3.
That's right, and it's a positive 15, right?
Yeah.
So how much is it?
5.
Perfect. And now write down everything else. And it's a positive 5. Very good, very good. Now, do the last part, negative 7 plus 5. How much is that going to be? 7. Negative 2. All right? So there are a couple extra things with integers. But they're not that much different. As long as you know the integer rules over there and use them, they are going to stay up there today. Make sure you keep them as a reference sheet at home and all that when you're doing homework. It'll help you out. All right, now we get to the last 3 problems we're going to do together, and it's all on grouping symbols and exponents. Now, these are the ones that mess people up the most. Okay? These are also the ones that are going to take the longest because of just how much stuff will be in them. For instance, let's just do grouping symbols first. So we're talking about parentheses here. Let's say I have 10 plus, and then you see this. What's that called again? Bracket. So then I go negative 6 and then here's a parenthesis. 7 minus 4 plus 5 and brackets. It looks a lot more complicated than it actually is. The first thing we have to do is parentheses, right? Start a PEMDAS parentheses. You always start with your innermost parentheses, right? Remember that? So what do I have to do first? Yes, sir.
7 minus negative 4.
You said it close. It's just 7 minus 4.
Mm.
Okay? So I have to do that first before I can do anything else. What is 7 minus 4, Nicole? 3. Very good. Now I'm going to write everything else I haven't used yet. Parenthesis, negative 6 there, positive 5 there, put some brackets around, and put a plus and then a 10. It's annoying because you write down a bunch of stuff, but the quicker you do this, the quicker you'll write it down and still be correct, and I can check your work as you go. Matter of fact, someone last hour, they had the whole thing right, they just forgot to put a 1 somewhere. And of course, so what happened? They got it wrong. Okay, so it's just those little things. Don't be careless, but try to write everything down and be as quick as you can. What do I do next? Yes, Seth?
Negative 6 times 3.
That's right. Now we're moving on to multiplication inside the brackets. So how much is that, sir?
Negative 18.
Negative 18, yes. So then plus 5. We go put a plus 10 on that side. Now, what's next? Still inside those braces, aren't we? Or brackets, yes, sir.
Negative 18 minus 1.
You said the wrong thing. Plus 5. Yeah. Negative 18 plus 5. So now we have to use our integer rules here. What is my answer for negative 18 plus 5? Raise your hand if you got it. Yes, ma'am?
Negative 13.
Negative 13. Now I'm going to write everything else. Now, do these brackets mean anything anymore? No, they don't mean a function. They're just separating the positive from that negative. So now, I look at these two and I say, okay, are they the same sign or different?
Different.
They're different. So subtract, keep the sign of the bigger. What is my answer going to be, Kent?
3.
You're so close.
Negative 3.
There you go. You got to make sure you keep the sign of the bigger one. Okay? Now that was just grouping symbols. Let's talk about exponents. We talked about exponents a little bit yesterday. Remember, exponents is just multiplication, right? So exponents aren't really that hard. We good? Can I erase this? Okay. Now, give me a number between 1 and 10, Tyreek. What?
8.
8. Give me another number between 1 and 10. Matt.
6.
6. Let's go 8 minus 6 squared plus 1. Now, notice this is not parentheses. We're just looking at how exponents really work. In this problem, you have to do exponents because that's the next step, right? So I look just right here. Whatever is squared is only right next to it. Since there's nothing surrounding this negative, that negative is not with it. So I only do the 6 to the power of 2. Yes, ma'am?
6 times 6.
Yes, and how much is 6 times 6?
36.
Perfect. So I put 36 there, and then that minus sign, or that negative sign, simply comes down with it. So it's like that, plus 1. Exponents aren't that bad. Now, do 8 minus 36. We just go in that order. How much is that going to be? Make sure you follow the rules. Nate?
21.
Negative 20 what? I just can't hear you.
29.
Not negative 29. You're close. Just this part. Negative 28. And then plus 1. What is negative 28 plus 1? Seth? Negative 27. Okay, that's exponents. So if you have an exponent, you only square or cube or whatever it says, whatever is right next to it. Okay? And to the left. Matt, is that clear?
Wait, why
Like-
would it be negative when it's negative 28 and then?
Different signs, subtract, keep the sign of the bigger. Okay? Good question, though. All right, and then number 5. On number 5, we're going to bring it all together. We're going to have integers, grouping symbols, squares, and cubes. So let's do 2 to the power of 3 minus, let's go parentheses, 7 minus 4 end parentheses squared minus 5. Now, I didn't make this one super hard, just enough so you can see how it all works. First, parentheses. Do we have anything that happens inside parentheses in this problem? Yes. Okay. What do we see inside the parentheses, Nicole?
6 minus 4 squared.
Okay, we see the 7 minus 4, right? That's what we need to focus on first, because it's inside the parentheses. So how much is 7 minus 4? 3. So now I'm going to write everything else down. 2 cubed minus, put parentheses back here, put a 2 for squared, and then minus 5. So is everything done inside parentheses? Yes, there's no more parentheses with stuff inside them that we have to do. Now let's focus on the exponents. So here's 2 to the power of 3. Who thinks they remember how much that is? Tyreek, what do you think?
8.
8, because it's 2 times 2 times 2. Very good. So that we need to do that. Here's more exponents. Let's go ahead and do that. What's 3 to the power of 2? Yes, sir? 9. There's no more exponents, so I'm going to write down everything else. Now, what do I do next? Yes, ma'am.
8 minus 9.
8 minus 9, which is how much? What was it?
1.
Nope.
Negative 1.
-1. Right there, you would have caused a little mistake, and that would have changed the whole problem, right? So now you got to be careful. There are different signs. You subtract, keep the sign of the bigger, which is the 9.
They're the same signs.
They're what?
They're the same signs.
No, that's a positive 8, and that's a negative 9. That's what I was talking about. Those are different signs. These two are the same sign, though, right? They're both negative. So what's the answer going to be, Nate? Negative 6. Okay.